usually people join after 7:04. Okay. It's live stream now, just for information.
Yeah, we're live now. We're welcoming everyone attending this panel discussion and also seeing us on the YouTube channel. We will start shortly. We're just waiting for a couple of people to dial in.
Sure. Abdullah's screen is full. My screen is okay. Presentation. Slides is.
Yes, it is.
Okay, good. Thank you.
Can we start, Sama?
Yeah, I think we'll start 2 minutes. Generally 7 to 7:03 after a couple of minutes.
Okay.
AGM is between 7 to 6:30 to 7. 7 is for all the general talk workshop, which is planned. Another 1 minute because already sufficient people have joined. But usually, our general plan is 7 to 7:04 is for entry. Then 7:04 will start. But anyway, today is a hectic time. We have a yes, we'll start. Good evening, for all the professionals, and welcome to our iShakti workshop, which is today November. From last 1 year, we are conducting almost every month one CPG talk for our professionals. So this is a special workshop because it's close to my heart because I worked so many projects. Maybe as a professional, you should move towards after some years of service, you need to go for repair, So we build and then we have to maintain it. Then we have to replan and reconstruct or refurbish, So today we have a workshop about structural repairs, refurbish, reinstate, and sustainability. So moderators are myself and my colleague, Mr. Ahmad Abdullah. So what we do today, just to update, we have some context to consider this workshop because, as you know, the climate is a big challenge for across the globe, across the governments. So what we did, we have, as an institution, we are planning various technical topics and seminars about climate emergency, climate, how to reduce the carbon emission, etc. So today's program is initially I just brief about an institution, then what we do for the topic, our climate, and then we have a workshop and introduction of our panelists, then workshop questions, then forum is open to the attendees. So many of you may be knowing about ISHakti, but just to benefit of others who are new to the institution, we are a 100+ century-old organization working for a structural engineering practice, and we have about 30,000+ engineers registered with us, and we have a regional group across the globe. Basically, we work for structural engineering and structural engineering professionals and structural engineers for a betterment of standards and practices and sharing knowledge, conducting seminars, etc. So why we chosen this topic as a workshop? Simple reason, as you know, it's called SDG, it's called Sustainable Development Goals, which is concurred by the United Nations for all the nations for a betterment of people and planet. So these are the 17 Sustainable Development Goals, which are agreed by all the governments. So out of this, for instance, the first is they're working on poverty, how to eradicate poverty, etc. So our action is towards climate action, which is SDG 13. Accordingly, our engineers are working, governments are working towards that. For instance, to understand where we stand as a carbon emission for a construction or built environment, there is two types of carbon emissions, operational carbon and another called embodied carbon. To give an example, a family of one car with 10,000 miles produces about 3 tons of carbon emission. More or less, operational carbon is well established, well controlled. They are improving standards time to time. Whereas embodied carbon, which is related to the built environment, a project which is about 5,000 square meter of floor area creates about 1,000 tons of carbon emitted into the planet. So that's what is the difference between the operational carbon versus embodied carbon. In this context, our institution has created a task force called Climate Emergency Task Force. We are working for how to improve the structures from concept to completion, including maintenance. So that CETG, you can go through our website, which is ishakti.org. Lot of literature available. It's free to download many literature. You can download. You can improve your knowledge. Majority of the advanced economies are working towards how to reduce carbon emissions. Just to give an example, if you see our built environment is giving almost 39% of the carbon emissions, which is embodied carbon. Out of this, if you see superstructure is contributing almost like 42%. So think about this and work towards carbon reduction and zero or neutral carbon structures. There's a way forward. Accordingly, we develop the standards, how to calculate embodied carbon and what are the items involved, what are the design parameters, all it's working in parallel. In this context, we wanted to have some sort of a workshop related to how the building can be reduced for carbons, not to demolish structures. That's what we mentioned as a title: think before demolition, think twice before demolition. That's what we took. So next is today our panelists. We are very fortunate. We have panelists from across the stakeholders, which is client, consultants, and contractors, specialist contractors, and suppliers. So it's a great honor to invite all of you for this workshop. Welcome you all, sir. I just give a brief about our panelists, and after that we go for workshop and discussion on the topic today. Our first panelist, Mr. John Eng, is almost 40+ years of experience particularly in the Gulf market. He is a promoter and founder of John Young Engineering Consultants. I'm going to give just a brief introduction. Then when you ask for the first question, you may introduce yourself, what services you are going to give for the market, and you can give answer for the first question. So John, as I said, is a consultant. He's an independent consultant most of the times. He works for the structural refurbishment and strengthening, assessing the structures. I worked many projects with him as well. Mr. Satyamurthy Nandagopal, he is also 40+ years of experience. Again, he's a civil engineer. He's vice president Simco Technologies. And simple word, there's no company in UAE who is not trained by Mr. Satyamurthy. Basically, every company who is in repair business, there's one person trained by him. That much I can say. So next is Mr. Mohammad Bithar, and he is a technical director for CCL. Welcome, Mr. Mohammed. He is almost 15+ years of experience. He works for CCL. He is specialist in PT and retrofitting of structures. Mr. Yado is a technical manager, joined with us today from Switzerland. He is a technical manager for Vessel International. Welcome, Mr. Yado. Mr. Jai Prakash, he is one more interesting person. He's a managing partner for Accord Specialities and Accord Building Contracting. And I'm sorry to say that I missed to invite his partner. Both are partners in the last 15 years, Mr. Imtiaz today. And he's a graduate and last 30+ years of experience in civil engineering, and 15+ years in running the company, both of them. And he's interested to work notable projects locally with government and semi-government clients. And Mr. Joseph Nabi, I think you don't need any introduction. He's a Sika general manager. He's working from almost 28+ years of experience, and is a key member for Sika structural strengthening and refurbishment of structures. He's instrumental in improving the product, etc. Welcoming you all. Thank you very much for joining today. And it's a privilege, and we are all here to listen from you. And basically, the idea is to introduce all of you, because in repair of structures, there's always a question: whom to approach, where to go, how to repair. There's a lot of questions for clients, but in particular. So there's a lack of professional service available. Hence, this topic is chosen and workshop is planned today. Thank you all. Next, we are going to move towards Q&A session. So what we do today's workshop, just to understand about house rules, what we do, initially we have a couple of questions for all panelists. First question, before answering, you may brief about yourself, or if you want to add anything, which I missed it. And then after a couple of questions for each panelist, then we'll go for the Q&A session for attendees. I request attendees to post your particular questions in the Q&A session or chat box, so that we can take up at the end of the Q&A session of workshop. So, welcoming you all. I'm going to start our Q&A. My first question towards Mr. John. So, John, are you there?
Hi, Sama. Yeah.
Welcome, Mr. John. Good. So John, as you know, you are a well-experienced person, and there's always a problem with any refurbishment structures, as-built drawings, and existing specifications. How do you go about it? Any structure, any client wants to proceed with already built and old or new, which is not available?
Yeah, thank you for the great introduction, Sama, and the question. So I'm really privileged to be here on this panel tonight. It's something that's very close to my heart. I was thinking yesterday about my father. He was a very keen environmentalist, and he used to cycle to work and back every day. This was in the UK, so the climate's a bit better. So I got my bicycle out today, and I cycled to work and back to put myself in the mood for the session. and I felt good. So it's a good for the climate, good for me. Yeah. So just to add to what Sama said, I came to the Gulf in 1983. My background's in civil structural engineering, but I've managed materials testing laboratories, and I've looked at corrosion and materials and systems to counter deterioration of reinforced concrete and cathodic protection. And about 25 years ago, I set up my company, Young Engineering Consultancy, and our mantra is sustainable structural solutions. So we look at the structure holistically. We also actually do surveys of architectural aspects of the building, finishes and the MEP, to understand the future of the building, its service life, the issues that are going to be involved with maintenance and repairs. So coming on to your question, Sama, the first thing one needs to do on an assignment must be a visual survey of the structure under consideration, and that's quite often a cursory survey around the perimeter of the building at ground level, maybe on the roof, inside some typical areas in the basements. But then it's essential to have as much technical information that you can about the building. So ideally, as structural engineers, we want the structural model, we want the design criteria, the design report, all of the drawings. But unless you're working on a brand new or a very new project, it's unlikely that will be available with the original, because the parties on the project, the client, project management team, the main consultant, sub-consultants, contractor, they will have demobbed, and quite often it's one of the last things that should be done on a project is to prepare all the as-built information and distribute that to the concerned parties. Here in Dubai, we're quite fortunate that the Dubai municipality is very well organized, and they set up a digital scanning service most probably about 25 years ago. So every building permit application that's made, the drawings are scanned with a unique reference barcode that's linked to the plot number, the project details on their approval system. So if you're the owner of a building, you have the title deed, and you can submit that to the municipality, and you can ask them to provide the archive drawings that they have on their system. And that for more recent buildings, it's more successful. If you go to some of the very old buildings, you may not get complete records, or you may get the drawings of the building that are not accurate currently. So if a building has refurbishment, it can be refurbished, modified, altered a number of times. So if that hasn't been done properly through the correct channels, you can actually get the drawings that don't show the current layout and details of the building. And then that can pose a problem if you actually refurbishing the building or modifying the building, because the drawings have to be updated for the authority. But if you can't get any drawings, there's no need to despair completely, because we now, with AI, we have some very good tools that you can carry out surveys with. So you can do a 3D laser scan of a building from different setup positions to build a point cloud. And from that 3D point cloud, you can generate 2D, 3D drawings. So that's good for the architecture. It's more challenging for the structure, because the structure's typically hidden by architectural finishes, false ceiling, cladding. So you can't see the column, the beams, the framing, and the layout. So in those cases, you have to do some survey work, say either conventional or the 3D laser scanning. Yeah, I mean, it's also, it can get drawings through the maintenance department at a building. That's where ideally the drawings are best kept, and the O&M manuals for the MEP. But sometimes when buildings are finished, the handover isn't done in a timely manner or properly, or the maintenance company changes. So it's quite often the case you can't get accurate, proper drawings from the maintenance company. Yeah.
Good.
I think that's a general view of the topic. If there's any specific questions on it.
Yeah, the idea is to introduce to you in the market, and they should know that what's possible for the as-built information. Good, thanks, John. My next question to Mr. Murthy. Satyam Murthy is there? I cannot see actually.
Yes, there? I'm there. I'm
Good.
there.
Thank you, Murthy. My question to you is, usually in service life assessment, what are the critical points to consider? And do you believe that available softwares in the market, is it suited to urban environment, or do you have to consider something differently?
Thank you, Sama. I'm really honored to be in this August seminar. It's my pleasure to be one of the panelists. I have been in the repair industry for really quite some time, from Saudi Arabia until now, more than 30 years, only in the repairs, but as a civil engineer, well, I'm afraid to say I'm going more closer to 50 years. Sama was kind enough to say that one of the, every major repair company here, they always have somebody or other who were working for me or trained by me at one point. It's really kind of him, but it's also the truth. Because I've been here for a long time, and why it happened was that before I became a consultant, I was a contractor. And it was a big advantage. It is never a disadvantage. Why? Because as a consultant now, I could understand the pains of the contractor, look at the practicality of the solutions that are being provided by the consultants, and that's a big help to the industry. Now to come to Sama's question about the service life. What are the critical items that to consider in the service life of a structure? One of the main, you see, this subject itself calls for a seminar of its own. So I will not go into each and every detail. And I have a disclaimer to make in this. I am a repair engineer. The service life, I have my colleagues back in Canada, Dr. Eric Sampson, who developed the software, who's not participating today, unfortunately. But I will try to do my best on the service life part of it. But when it comes to repair, I'm sure that I can contribute definitely a lot. Now, what are the critical points to consider in service life? Transport properties of concrete is one of the main important factors that we consider in the calculation of the service life of any structure. The second one, important one, is a chemical phenomena. Mr. Sama asked me a question, how do I find it different from, or probably that's what he implied, different from the other software, is that one of the important things is we consider, we as a service life, which is, we are the ones who developed a software called Stadium. And the Stadium takes the full array of chemical phenomena, not a simple either one ion or not. Then talking about the transport properties, the next is what do we test for, and what is that we should look for? We should look for the volume of permeable voids. That helps in determining how fast the ions can travel into the concrete. Moisture permeability, because moisture plays a very big role in getting the reinforcement corroded. Then the diffusion of contaminants itself. You see, not only we are talking about the contaminants such as the chlorides, sulfates, or hydroxides, and we are also talking about the reactions that are occurring inside this hydrated cement and with the environment around it. Then another thing is that the Stadium ME, we have developed the Stadium Middle East to cater to the Middle East ambient conditions. Because I will address it later, because one of the questions that Sama has asked me to address is that we are not taking it, what is good for North America is good for the world. No, we are building something for here in this country for this environment. That's all about the stadium, Mr. Sama.
Thank you.
If you can move on to the next one.
Good. My next question to Mr. Edo. Edo, I'm not sure how far you know about local conditions here. Every building you name it, it's a PT systems here. So last 2 decades in particular, PT is very popular. Consultants got an easy job because all horizontals will be by PT. So we have a question because how PT systems, which is old, how to inspect whether my PT systems are working or not, how to repair, what are the challenges to repair PT structures? I'm sure you understand what is our problem here. So, Edo, floor is yours.
All right, thank you very much, Sama. And it's also really my honor and pleasure to be able to participate in this panel. Thank you for inviting me from Switzerland. I cycle to work also today. I do it every day. So, John, I definitely can promote it. I'm based in Switzerland, but I'm Dutch. So I'm cycling all my life. And I can definitely say that it's a good thing to do. I have been currently based in Switzerland, but I have been working and living in Abu Dhabi actually in 2005. But my background is structural engineering. Always been working for consultants and contractors, and I worked on the Sheikh Zayed Bridge in Abu Dhabi. So I know your region a little bit. But my current role is with VSL. So VSL is a specialist contractor. Maybe mostly known from PT and its bridge construction. But as Mr. Sama said, the future is to try and preserve our existing structures more than trying to build new ones. We definitely see around the world a tendency to have more attention to existing structures. And that's where it all starts. I think also recently we have seen around the globe quite a few catastrophic collapses of existing structures, and that has given more attention to the subject of knowing what your current status is of the structure. So clients are interested or need to know what is the status of my current structure. And if you talk about PT structures, then obviously knowing the condition of the PT is very important, as it gives the structural safety of the structure. It provides the compression, but you don't see the PT. So yes, there have been recently, in the recent years, quite a lot of developments in inspection techniques of post-tensioning. And different countries have different, there's countries that are more developed than others. Some countries have already have quite extensive guidelines and codes to specify how to carry out PT inspections. But what maybe I'm the wrong person to say it because I'm from a PT specialist company, but we do find it very important to state that these type of inspections are done by specialists because you need to know what you're looking for. And then the developments of NDT techniques are going quite fast. There tends to be sometimes a bit of unclarity of what NDT technique to apply. Basically, we do have the experience of the vast range of NDT techniques, and each NDT technique does a certain thing. So, for example, if you're interested in corrosion, then you have to have one technique is particular to find that. If you're interested to finding broken wires in your strands, then you have to use a magnetic flux technique. So the knowledge is quite vast in knowing what technique to apply and what the reliability is of that technique for detecting errors. But in the end, the challenge is to find corrosion in grouted PT tendons, because we do find in historic buildings or bridges, we have found voids in grout, so that these PT tendons, the PT strands are protected, are passivated by the grout. But the grouting techniques have developed over the last 20, 30 years, and historic structures tend to have voids or soft grout, which make these strands corrode. So you're trying to find the risk of corrosion in your PT structures. And then once you have found PT tendons that are broken or that are a high risk of corrosion, quite far in corrosion, one needs to replace these tendons. And also that is, there's a lot of development in regards of replacing tendons. And we currently are busy in Hong Kong, for example, to replace external PT tendons with a clamp. In other countries, we replace tendons cutting, but there's various developments of detensioning existing tendons and putting new tendons with maybe more durable PT systems that are less dependent on the dependency of grout to provide the passivation of the PT tendons. And then finally, in regards of development, some words about monitoring. Monitoring is also, it's like Mr. Murthy was saying, all these subjects that we cover here could be a seminar on itself. Monitoring is also a subject that could be a subject on itself. But one of the ways to inspect your structure is definitely also monitoring. But then it depends on my view in regards of monitoring is that you have to know what you do with the data. Sometimes monitoring is applied to just get a lot of data, but then you don't do anything with it. But if you know what you're looking for, there's definitely different monitoring techniques available that can help you maintain your current structure. For example, acoustic emission. If you have found during inspections a higher risk of corrosion, if you apply acoustic emission, you basically listen to the broken wires, and then by the frequency of how often you hear broken wires, you can say something about the current status of your PT tendon. But then you apply a specific monitoring technique for something that you need to know and want to know. So yes, that's a short introduction on the importance of inspection and maintaining your current structure. And all the repair works or strengthening works obviously starts with that. Like John was saying, you need to know the current structure with drawings or other techniques. Then you need to inspect and know what the condition of the current structure is. And then you can decide on what kind of repair or strengthening do you apply to extend the design life of the structure.
Thank you, Mr. Edo. And next question, I move towards Mr. Mohammed Bitar. Mr. Mohammed? Yeah, generally a client who is not having knowledge of structural repairs, this is a big challenge. Whom to contact, whether is a or a contractor, a subcontractor. This is always a problem in this part of the world. So can you please highlight what are the steps followed during for structural restoration? Because there is no proper consultants in the market. There are very few. I'm sorry to say there are very good experts are available, but whom to approach for what problem? No clue. So Mr. Mohammed, please, can you please highlight these challenges with the clients are looking?
Yeah, sure. Thanks so much. Just quickly, I'm technical director of CCL. CCL, like VSL, we specialize subcontractor designers, mainly post-tensioning, pre-stress, but we also do retrofitting of structures. Personally, I've been here based in Dubai since 2003. And I come from a consultant background. So Arabs, Gifford, Rambo, Rambo now, before used to know as Gifford, and now CCL. We just set up CCL technical office in Dubai last 8-9 years, headed by myself. And the specialties are pre-stressed, concrete, conventional concrete, retrofitting, strengthening, restoration of structures, industrial flooring, that also includes post-tensioning. So yes, in general, if I want to put the process, all our contacts, most of our contacts come directly from the contractors, because being a subcontractor, we have contacts directly with the contractor. Now, I do wear separate hats as well at CCL. I do some business development from time to time worldwide and in the Gulf region. And I do, because I have the background of the consultant, I do go and visit consultants, and I do introduce CCL to them and say, look, this is what we can do if you have a problem in restoration of structures. And that is doing well, because I do get calls from my personal contacts, from the contacts I do in personal development, that the consultants say, look, we have a job here, a job there, and we put your name forward to the contractor or to the client. So let's meet up and see if we can do something. Now, if I want to say, we always work under the contractor because of the process and the paperwork and the licenses. As a subcontractor, you need to work under a contractor. So even if the client contacted you or the consultant got in touch with you, we still can be nominated by the client or the consultant, but we need to sign under the contractor. We will not be able to go and work directly to the client without be a contractor being on the job. Okay, so yes, we can get in contact directly from the client or the consultant, but a contractor needs to be on board for us to do the job. Now, if I want to move very quickly into the process, if I want to put it in very quick bullet points, is we need to understand the scope. And then when we say the scope of what I see in the market, it could be a construction issue. It could be a contractor having construction issue, something being cast not correctly, or there's a fault or a bad concrete patch or whatever it is. It could be a fire. It could be something happened to an existing building and had a fire. So this is a problem. You need to find a solution for it. Or it could be something that the client wants to change. Like, you know, in 2008, where we had the financial crisis, a lot of projects really stopped, and now things are picking up over the last 2, 3, 4 years. So a lot of clients, they come and say, okay, I have a building, it was going down office route, and now I want it to be a hotel apartment. So you can imagine every room with its bathroom and so on and so on. So there's a lot of MEP changes, there's a loading changes, there's a usage changes. So this is a challenge. We get clients that they have a residential unit and they're selling it, and you have customers, they want to do duplexes. So they want to open, floors, they want to knock walls, they want to do big openings. Shopping malls that being rented out to big, franchise, and they want to do escalators, like, for example, without naming names, Zara or Google, they want to take something and they want to do changes to their existing rent. And these people are coming into rent for years. It's not, short term, it's long term. So we need to understand the scope. And once we understand the scope, what is required, the first thing we usually do is we go on a site visit of the existing building, just to try to understand and get a feel, what do we have? If a client wanted to buy something or do a change to a floor, maybe we cannot do any strengthening from the bottom, or we need certain permission from the bottom because there's an existing client on the lower floor. So there's restrictions on site that we need to understand, and we get a feel of that. There could be also restrictions architecturally. If something is being built and need to be changed, and we cannot come and have a full flexibility, maybe we need to understand that architecturally. The next step is what John said, is try to receive as much information as possible. First of all, the as-built drawing, if it's built, and if it's being built, the drawings are there, so that's easier. But the challenge comes when a building is being built or is being put on hold for years, and then suddenly you want to look for the drawings and look for the models. Now, if we have a model, it will be great. If it's an existing building and the consultant is present, then it's easy to get the models, and then we can do the alterations. But if the building is being old and there's no model, the most important thing is to have the drawings. If the drawings are there, we can do reverse engineering and try to create the model from start. Because we can do survey, we can do a little bit of hammering on site, like soft stuff on site. We can see what the existing reinforcement is. We can do coring, we can do tests, whatever it is. So after that little visit, we can then, and looking at the models, then we can dig deeper and try to do the analysis. Either, as I said, reverse engineering, or do the model, our own modeling. If it's PT and then we need to cut some tendons, we can look at what tendons we're going to cut. Can we do external PT strengthening? Can we check it? What's the possibilities that we have of the strengthening? If there's a cracking, we could do crack mapping. If it's fire, we need to look at the areas that are affected by the fire, and we can classify them. It could be smoke damage, it could be some damage, it could be cleaning, it could be really knocking and building something again. If there is PTs, if it's a pre-stressed slabs, we need to look at how much the damage is the strand, need to go to the lab and need to test it. How was the capacity of the existing strand? Can we depend on it? Do we need to replace it? So once we do that study, then we'll be able to come out with a solution. So we got the results, we got the surveys from site, we know the constraints from the site, we know the analysis, we can give the best, probably cheapest, durable, technical solution to the client. If that is accepted, the next step is actually to do the drawings to get the approvals from the consultant and the authorities if they are present. Once that passes, then we go into site. Hopefully when we go to site, there's no surprises. This is not completely true, because you always get surprises once you actually go and do some of the work, the actual work on site. But the surprises will be minimum because we follow the correct steps. We prepare the method statements, we get the material on site, we prepare everything, and then the operation team can start working. And once we work, if there's places that need to be isolated, back propped, whatever, we take the necessary measurements as to the method statements. This way we can finalize the retrofitting or the restoration or the changes, because we call it restoration, but sometimes it's just changes that the client or the tenant want. So if we follow these steps accordingly, it's a happy ending, because everything is done nicely in the most economic manner and effectively. Now, if I touch very quickly on something important, is what's the roles probably played by each of the players, if you like. And I think each one of the team has a role to play. The client, other than paying for it, the most important role, he needs to be realistic. The client needs to be realistic. You get some clients who are not really realistic. They just want something yesterday and the cheapest, and so you need to be realistic. The consultant architect, I think you need to just be cooperative and provide the necessary information. If he have the information, just put it forward, because the more information we have, the easier and the faster the process. The contractor needs to understand that there's a process. He cannot say that I have a problem and then carry on working in the affected area, because by the time we come back, he builds a wall that needs to be knocked, or he put MEP that need to be taken off. It's going to cost him money again. It's going to delay things. So if this area needs to be repaired or restored, he needs to include that in his program, isolate that area, and we try as fast as possible move into that area to get his work going again. A lot of jobs you see the contractor says, I got a problem, and he carries on working. He builds his work at the MEP, and then it creates more problems than solutions. And the specialist, I think you need to be honest. find the most effective economical solution for the project, and work in parallel and communicate with everybody. So this is like a very quick steps, roles, responsibilities for your question. I hope I just covered it as fast as I can, as clearly as I can.
Thanks, Mohammed. Yeah, my next question goes to Mr. Jay Prakash. I think he is the last in the chain. He's a specialist contractor, I believe. So, Mr. Jay Prakash, I think generally, what are your recommendations for stakeholders? What are your recommendations so that you can have a very good repaired product which can be durable for a long term, so that we don't need to demolish the project?
Thank you very much, Sama, for giving me this opportunity. I'm really truly honored to be on the same panel as Murthy sir and Mr. John, whom I know and whom I'm working with also. Just let me have a small brief about myself. And I'm an engineer from BMS College of Engineering, Bangalore. 31 years still going on, and working in various capacities. And 2007, we started a company called Accord Building, Contracting and Accord Specialties, along with my dear friend, Mr. Mohammed Imtiaz. And let me take this opportunity to thank him for being a part of my this long journey. Thank you, Imtiaz. Sama, coming back to your question, my colleague from CCL has almost answered that question actually. See, actually, as he said very correctly, who are the stakeholders? Stakeholders are clients, consultants, and contractors. Okay, but when you take a new building, there is one more stakeholder, that is the governmental authority, like Dubai municipality is there, DDA is there, Turkish is there, Jafja, like this. Okay, but in repair, the government authority is not that much involved. Okay, for the general repairs and everything. Now, coming back to the client. Client is the most important person apart from paying for this one. Okay, he should be having an idea about what exactly he wants. Okay, but unfortunately, most of the clients, they don't have a clear-cut idea about what exactly the repair. They think repair means some just patching up. Most of the clients, I'm not saying everybody, most of the time we encountered clients like this. Okay, they say, and they think they don't employ a consultant also. Okay, a lot of the time we get a call, we go, we see, and they ask us, okay, propose repair and start the repair. And what they want, cheapest solution. Okay, they don't involve a consultant, and that will lead to a lot of issues. Okay, for example, just one of our clients, just I'll give a few examples. They wanted to have a CFRP for one structure. Okay, the client, he just doesn't know why the structure has to be strengthened. There is no parameter. We did not get any design parameters for that one, but they gave us the quantity and they gave us the how to do it. Okay, they said put 3 layers, 600 GSM. Okay, then we went and we asked the client, and structure seems to be looked like in an excellent condition. Okay, we went and we asked, they said no, we want 3 layers. Okay, then I had to approach a manufacturer, and we have to take the design from the manufacturer, and we have to propose the design and everything to suit the BOQ quantity. The BOQ quantity also, the client said, oh, I want this much quantity. Okay, fine. So this is one of the problems where the cost just shot up, number one, and number two, delays. You know, if you have a design and everything is available, we know what exactly we are doing. There we need to study the structure, and we have to have a discussion with the manufacturer and to give a proper design to the client, submit it, and then get the work done. This is one of the things. And second thing is, if you have a corporate client, for example, okay, something like MR, Nakil, something like this, okay. What they do, by the time they take decision, it will be few months to 1 year. Okay, but the damaged concrete, spalled concrete, that doesn't wait for the bureaucratic system of the corporate client. Okay, it increases the scope. By the time you go there and first you visit, you give a quotation according to the scope of work and all. After 2 years, you go and visit, the same scope has increased. Now that we all will come to the square one, saying that no, we have already got approval only for this much of area. We cannot give more. But structure is structure. You need to have repairs. Then ultimately we had to face a problem. Okay, you repair this one. By the time we try to get the approval for the other area also. So just for your example, today morning we have visited one facilities of one governmental authority. Okay, the same facility we visited 2 years back. There were cracks in the floor and there was a slight settlement due to the leakage of water and all. 2 years back, we gave a proposal and everything. They said, okay. They did not give any approval. And after 2 years today, we visited. I was stunned to see that it's settled and you can see through the walls and structures, the crack. It was in a very dangerous condition. And now they're asking a solution today itself. It's very urgent. Okay, and when it comes urgent, everybody starts running here, there, and all. But the notable thing here in all these kind of clients is there is no consultant involved, proper consultant. Okay, they just want to approach the contractor directly and get the thing. And today also, even today, I was told that you propose the solution for this one. Okay, they just understand that we are contractors specialized in executing the work. We are not designers, basically. Okay, you need to have a specialist designers like Mr. John is here, and I'm privileged to work with Mr. John and Dr. Ashraf Bidda and all, and I have a great regard to Mr. Satyamurthy Venugopal and all. So there are stalwart, lot of stalwart consultants are there, but we end up like this with these clients. It's not only the money, it's the time, it's the complicated things for the contractor also. So client is very important to have the awareness of the problem. Okay, and as far as the consultant is concerned, yes, mostly I don't see a problem with the consultant here. Because whomever I came across, they are very well knowledgeable and they know what they are suggesting and they know what they are doing, inspections, everything. So better they carry out a good conditional assessment based on the facility reasons and all. Okay, then contractors, this is another problem because there is, even though to become a contractor for, you need to have a concrete restoration in your trade license by giving an exam and this thing and all. Most of the contractors, they are not followed and there is no definitive government requirement. Checking is not there. Like what you do it in the new structures. So every Tom, Dick and Harry is coming and saying that, they do repairs. They think that it's very easy. I heard one contractor telling the client that he's going to use the most expensive chemical in the market. Okay, he has no clue about what he is using and about the properties of the material or anything like that. So contractors should also be well aware of all these things. And more than anything else, I prefer, it's a wishful thinking, governmental regulation should be very clear cut for the repair scope. Here, governmental authorities are not that much involved. Client can either go with the contractor directly or appoint a consultant, and consultant will propose a design. Contractor will do that, consultant will do the inspection, and contractor will submit either pull-off test and the cube report and all these 1 or 2 or 3 tests. That's the end of it. There is no definitive guidelines and inspections from the governmental authority. When the governmental authority proposes a guidelines, they come for inspections like how we have in the new structures for every foundation, slabs and all. There is inspections is there. The third participant and for the stakeholders, the fourth stakeholder should be, I prefer, as a governmental authority. Thank you so much. I hope that answered the question.
Yeah, thank you, Mr. Prakash. Your hands-on experience, thank you for that. And my next question goes to Mr. Joseph. He is the man connecting all of us, being a supplier. He knows everybody. So I just put a question to Mr. Joseph. Basically, I can see there are a lot of materials available. It's always a challenge for a client and consultant to choose what material for what purpose. So how to choose right material for a given situation? For instance, this micro concrete versus dry concrete, maybe a injection, there is a lot of variation, but client doesn't aware what is the difference between, say injection is one injection. They got for a water leakage, there are various types of injection when you see your data sheets and all, but it's very complex for a technical guy to understand. which product for what. In general, I know it's a very big topic. I know the aim of this workshop is to understand where we stand as a repair industry, to know all the professionals. That's the main aim, actually. So, Mr. Nabil, please update us. Thank you.
Good evening, everyone. It's my pleasure and honor to be with all this expertise in our construction. Really, the topic of selection of material or product in repair systems is very complicated. Generally, in Sika, we have two main sources for the selection of products. If we follow the US practice, we will find the ACI 546. If we go to European Union, we will find the BSEN 1504. However, in Sika, we prefer to give the definition of repair system, not a product. As you explained, exactly if I'm in front of a technical data sheet of any supplier in construction chemicals, you will be surprised that this product only give you the properties of such a product. However, we still, as we mentioned, the definition in Sika, we put concrete repair and protection system. So we should identify exactly what is the requirements from the customer or for the client for this specific case. Then we provide the proper system and detail the products. Coming back to the selection of the product, like in BSEN 1504, normally the guideline or the code give us the minimum requirement and how to do the quality control and the CE marking and all related to the product performance itself. The most critical part in selection of the repair material to understand exactly what is the purpose for using of this product. In structural repair, it is more complicated because it is not only for me to stabilize a crack. This will give you the solution. If we have a crack, we have to ask 6 questions. If this crack is structural or non-structural crack, what is the width of the crack? What is the depth of this crack? If this crack is, what is the substrate condition? It is dry or wet or damp substrate with running water. And finally, what is the surface temperature? What is the temperature of your structure? Then we can select the proper injection material or material to be used for the stabilization of the crack. Accordingly, the guidelines or the ACI or the BSEN just give us the minimum requirement for the product. But the challenge here, what is the requirement? Normally, if we go to the new generation or next generation of repair systems, there's a lot of requirement. We'll find a requirement from the market itself regarding the type of the repair mortar. It is normal or slow set mortar, polymer modified or non-polymer modified. It is structural or non-structural application. What is the type of the mortar, rapid setting or lightweight, durable grade, etc. Also, we should advise our end user, if it is owner or it is a designer or it is a contractor, what is the added value for him. For each of these clients, they have specific requirement. For example, the owner, he need a cost-effective solution with long durability and with available guarantee, while the designer will look for easy product selection and some specific requirement like carbonation resistance, low chloride permeability, high compressive strength, modulus, and layer thickness, etc. While the contractor, he will look also for a cost-effective solution, layer thickness, better finish, and better workability and project support. Again, I will come back to the repair and protection system. It's very important in selection of the full repair and protection, because if we have a problem in the structure, we should understand the root cause of this problem, and we have to address these major reasons for the deterioration and to repair the structure and to ensure enough durability for the selected system. The topic is not easy, as we have a lot of challenges. Every project is different. We don't have a certain universal or versatile system for every and each thing, but we can we tried the last few years to make some simple selection charts for each of the technologies, like how to select a proper injection or crack repair material based on the 6 questions we raised. Also, we can provide different structural strengthening systems based on the type of the element and the type of the straining actions. Accordingly, the consultant or the contractor or the engineer can select easily, and so on. So the selection of the product or the system is a little bit need some understanding of the requirement. And in Sika, we try to help all our customers and clients, contractors or consultants, to have the proper selection of the system. Regarding the latest development of the new generation of repair mortars, now there is a lot of, as you mentioned, Sama, in the beginning about the sustainability. Now, within the coming few years, sooner or later here in our GCC, we have to follow the global trend. We need to provide sustainable and environmentally friendly repair systems and products. We have to work on a lot of challenges we are facing currently to reduce the CO emission. We can see the new trend now. We need to look at reduced working steps in creating 2 products in one or 3 products in one. Also, we have to address the increased durability requirement. Also, we need, you hear me? You need also to address demanding applications, like application of concrete repair under dynamic loads, which is currently in industrial projects or in traffic structures. Only one German standard, the ZTV. In Germany, they have such requirement and such testing. We have to develop such products in our markets. Also, we have to look for increased, better performance and realistic job site testing, easy to be tested. In the end, I would like to mention that the new repair mortars will provide a lot of solutions to us, especially if we look at the new Portland cement will be available in the coming few years. This green cement will need to have reformulation for all the concrete repair cementitious mortar in our world. This is a brief from my side, and thank you.
Thank you, Joseph. That's good. Actually, the checklist which you prepared will be a very good handy for the market, which product is for what. Because if you can educate even all the consultants and everybody, it will be very interesting actually. Checklist for choosing a product.
Yes.
Good. I think we completed one round of Q&A. I request we'll take some couple of questions from attendees if anybody want to post. And in the meantime, I'll run down a few questions. I have a few questions. We'll quickly go a minute because of the time lag. We end up maybe 8:20, something like that. So my question towards Mr. John, actually. Mr. John, you are mute actually.
Okay. Yeah.
John, actually, as a client perspective, when to carry out structural assessment or inspection for any facility? Should be a regular or after 25 years of initial period, or once you see a crack?
Yeah, no, very, very good question, and one I'm asked very often by different building owners or FM managers who are responsible for the building and the safety of their building, both internally and externally. And there are some codes and standards that give guidelines on the frequency of inspection and the type of inspection, the detail, and whether you carry out testing as destructive testing, semi-destructive testing, or NDT. Yes, sometimes a structural assessment is necessitated by if you're refurbishing a building. So maybe the building's been stripped out, and you find some deterioration or defects in the concrete, corrosion of the steel, that people weren't aware of. So you can have a project for refurbishment, and this is sort of comes onto the picture quite suddenly. So it needs some immediate input to look at the implications, if you need any propping to temporarily make things safe, and then you look at the repairs or strengthening. I think maybe to look at it from personal experience, the most sort of common situation we do structural surveys in is very reactive. If we have a very old building, so if you think about what happened in Florida this summer with the 40-year-old building in Florida that had that collapse, there's people in the real estate sector here, property and construction, have sort of seen some similarities with the environment, the high temperatures, high salinity, the age of some of the buildings, particularly in the Northern Emirates, can reach 30, 40 years. So that is a real cause for concern, and you should have some sort of program of periodic inspections and surveys of those buildings. I mean, the type of survey can be very cursory. So I guess the most basic survey people do is what you call a dilapidation survey. So you can't see the structure in many locations, but you can see the architectural finishes on the facades, on the roof, in different areas. So you can record defects like leakage, cracking, and you can get a general idea of the condition of the building with quite a quick visual photographic survey. But if you've got some specific concerns like excessive deflection of an element, or serious cracking and spalling of the concrete in some areas, then you have to have a more targeted approach. So you do your complete visual survey, and then you would look at a program of testing, destructive testing, backed up by a larger number of non-destructive tests to verify the findings on a representative number of the elements. And you're looking to check the integrity of the reinforced concrete, and you're also looking for the adequacy of the elements with regard to strength. So yeah, I'd say the most common time we get called in is if maybe somebody complains to the municipality. So if you have a building and you have a structural issue, typically it's not a serious structural issue that's affecting the ultimate limit state or the global stability of the building, but you can have chunks of concrete or masonry that crack and spall off the facade, and that can be very dangerous because a lump of concrete can be very heavy, and it can be fatal. I remember actually in the years I've been here, there have been fatalities in. I remember, I think in Ras Al Khaimah in the Northern Emirates, there was some very old single-story buildings. I think they had like a false ceiling, so the suspended slab was hidden, and you had corrosion, loss of section. You have sheet delamination, so you've got a big plate of concrete that's spalled off from the soffit of the slab and fallen. And I think this happened when people were sleeping in the building, and there was a fatality. So it is a very serious situation. That building didn't collapse. It was much very indeterminate what the actual structural safety stability was, but it wasn't going to collapse immediately. But having these large lumps of concrete falling, particularly under a false ceiling, is very dangerous. And if you look at sometimes the maintenance history of these buildings, you can have cracking and spalling, corrosion of the steel, and then it's not looked at by anybody with any engineering knowledge, and certainly not a structural engineer. So the maintenance guy will slap on some sand, cement, and repaint it, and then it'll last a year or two, and then it'll crack and spall again, and he'll come back and do the same thing, then he'll leave, a new maintenance guy will come. And then when somebody who knows about structural stability and adequacy comes along, you can find you've lost the major section of the steel bar, and the concrete integrity is gone, and the member is seriously weakened. And that's not good for safety and stability of the building. But it also means when you come to do the repairs, you've got much more work to do, and you may be at a point where, you know, it's actually more economic to demolish the building, which is the reason we're.
That is the last resort to consider, John.
This is what we're here tonight to try and avoid demolishing buildings. So we need to have these programs of preventative inspections and preventative maintenance to stop reaching that situation. Yeah.
Thank you, John. I think you got a wealth of experience. Definitely, we need to consider. You know.
Thanks so much.
My next question goes to Mr. Murthy. Mr. Murthy, I know you are a Vice President of Simco Technologies, which operates across the globe. Can you please tell in short what is the learnings from international experience to our local?
Amma, I hope that I'm not going to disappoint you, because my experience here is that we have learned a lot here. Sometimes we end up educating my counterparts back in North America or in other countries. Yes, but it does not mean that they have something, you know, which they have a lot to contribute. I come to that later. This is a place where, when it comes to the concrete repairs, this is a place where we can learn, improvise, revise the standards even. There are a lot of people from the Middle East who have contributed to the ACI standards. For example, if you take Sika, my colleague Joseph is here. When Sika was producing some of the construction chemicals, I'm talking about 1990, roughly about 31 years ago. And those construction chemicals, they had a problem in getting it adapted to the Middle Eastern ambient conditions. So they have to adapt. They had to learn a lot. And the learning, most of it was on the field here. So they had to rewrite the whole thing. Now you go to Sika, they have everything that is required for this country or for these countries. So we could really learn a lot here. I have learned a lot here. I ended up telling the people, hey guys, because this is one of the most aggressive environment that you could ever encounter around the globe. So the problem that we face with the concrete, not only because of the environment, it's a combination of environment and the workmanship. You know, when you take a workmanship, it's not as good as you expect it or is being done in Germany, for example. I have seen some of the construction in Germany where they say, I asked them, okay, what kind of waterproofing you use for your basement? They said, we don't use any waterproofing. They call it white waterproofing. White waterproofing is the concrete structure itself, takes care of the waterproofing part of it. But here, we have 2 layers of waterproofing. We have a good concrete, and still cracks and still leaks. So we have these problems here. It's because of the workmanship, as I said. Now, coming to the question that you asked, don't we have anything to learn from them? A lot. We have a lot to learn from them. Why? Because until a few years ago, not only in the Middle East, in many parts of the world, is that what is concrete repair? Sand, cement, mortar. That's it. You go there, chip up something. I think John mentioned it in his previous disposition that, hey, you just go there, use the sand, cement, mortar, paint it, finish. And that was a concrete repair maybe 20, 30 years ago, but it's not there anymore. So if you talk about concrete repairs here, it's only that much old. But whereas if you go back to the Western countries, it's really old. It has evolved. They have still the standard that we have are coming from them. Even though that we are asking them, hey, we have to modify the standards to suit this, but still the original standards came from there. Joseph was mentioning some of the standards from there, but if you want to go for a repair, you have two that I would always recommend. You go to ACI 562 that talks about the system of evaluation of repair and the repair systems. And for the materials and all those things, you can go to what Joseph has said. And the ICRI has got the concrete repair manual, CRM. And that is really one of the best documents that has been produced internationally. ICRI is International Concrete Repair Institute, and that has been doing a wonderful job of educating the engineers around the world in what shall be the standards. There are a lot of things that we can learn from them. In addition to what I have said, I want to highlight 2 points slightly out of what Sama has asked me, because I believe that we are running out of time, but I thought it is very, very important for us to mention. It's in relation in the context of the topic of this seminar, saving or having a lesser carbon footprint. If you take the Stadium, which is a proprietary software for Simco Technologies, when you are going to go to the marine structure owners or infrastructure owners, if you are going to build a port today, it's going to cost you $1 billion dirham, or in some countries it could be $1 billion. When you have, port in those days were being built for a 50 years of service life. And if it is not built properly, then the service life even becomes shortened. It's horrible to go. By the way, now we are talking about 75 years and 100 years. We play a big role in that, in designing those kind of ports for a 75 years and 100 years of service life. Imagine what happens if you are going to build or replace a port with a new structure worth about $1 billion, and then instead you find out what is the service life of the remaining service life of this port, and then you go for the repairs. The kind of carbon footprint that you can save is enormous. It could be 20% of what you would actually be spending by building a new one. So that's a big saving. Then I will give you a real life example of what I faced in another country, where a plant or a contractor built a chimney 175 meters tall within 5 years of it being built because of two things. One, a wrong specification. Two, not a good workmanship. They put in the protective coating. Joseph was talking about not only the system of repairs, but also your protective measures to protect your structures. The protective coating that they have applied for this particular structure was very good against hydrogen sulfide, yes. But the problem that they had was the threshold of the temperature. The threshold of the temperature was more than 70 degrees Celsius, and by that, the epoxy started failing. So the coating has completely failed, which is the wrong specification. But I happened to be there and tried to look at how good they applied it. That's another story. So with the result, the concrete shell has lost 25% of its thickness. And then the consultant they employed a consultant from very well-known consultant from France, and he came and said, you have to demolish it and rebuild it. Look at the pain of the owner. He was not thinking about the carbon footprint, by the way, but we were thinking about it. So he said, oh my God, how do I go to the board and get it approved to build another chimney, demolish it and build with it only 5 years old? Okay. The project was referred to me. I went there, we saw it, we gave an engineering in order to repair it. He was kissing our hands saying, my God, you saved our life. Yes, it is. And not only it is, the cost was less, carbon footprint was less, and the time that he had to shut down in order to get this one was enormously reduced. These are the two examples of this. What we have to learn from the international practices, if the international, or if somebody would have followed a proper specification to make sure that chimney was built with the international standards, this would not have happened. So We have a lot to learn from there. And this is the best country to have the best of the both worlds. You know, you have international experts here who are sitting here. Take John, who is from a Western country, who is sitting here, and many people around the world. They are here to tell us or to share their experiences. And we are going to be executing it in one of the most aggressive ambient conditions, and which is a learning becomes both ways. So we contribute to them, they contribute to here, and this is a melting pot, the best place to learn. Thank you very much.
Thanks, Murthy, for your quite good informative reply. So as you said rightly, for civil engineering, I think Dubai is the right place, or the Gulf is the right place to learn. You know, we have got tremendous great structures as well as repair industry. Sorry, we are running out of the time, so we need to cut down a few questions. So there are some questions. We'll take it from the audiences. This is one question. It's a general question, but it's interesting. Why is it, I don't know whom to take, which panelist. Why crystalline waterproofing is not used in a leakage of basements? Because generally people adopt injections. Who will take this question? I'm sure Murthy,
I can take the question if it is, if I am allowed.
Who want to take? Sorry.
Let Murthy say something. I've got a few comments as well afterwards.
Okay. Mr. Murthy, please.
Okay. I only hope that me and John are not going to contradict each other.
I'm sure we won't.
Okay. See, the question, it's a good question, and this has been lingering with us, and I have had some personal experiences, the good ones and bad ones as well. You see, in theory, the crystalline waterproofing works nicely against the negative water pressure, no doubt about it. But I faced a situation where I go there because of the, you know, this was my previous life as a contractor. We started injecting it with the polyurethane, and then the polyurethane contaminated the concrete, but the water was not stopping because water was shifting from one place to another place to another place. So you keep on injecting it. I mean, the entire concrete was going to be filled with polyurethane in all its pores. Then they said, okay, all right, let's go for a negative waterproofing. So we started applying it. It was not stopping. Then we called those guys from Canada, and they came here and said, hey, you have contaminated the concrete fully, and it's not going to stop. Anyhow, eventually we solved the problem. This is one of the key infrastructure in this country. It's in Jabalali, and we solved the problem. But what are the takeaways? The takeaways were that when I was inspecting a 6-basement building, it was leaking everywhere. It's not in a crack, it's not in a spot. So what we did was that we gave a methodology. This is what we did. What we did was that we used the negative waterproofing to the entire basement, 6 and 5. And then we expected some leaks. The leaks came. When the leaks came, we went back and injected with the polyurethane. It was a combination of negative waterproofing as well as the polyurethane. The problem was solved. Actually, I wrote a paper on that. The paper is still available on the internet, and it was really, it solved a problem. To answer the question, no, we are not shying away from the negative waterproofing using the crystalline. Yes, we can do it, but one has to be extremely careful about what is the claim made by the manufacturers and what exactly is happening on site. There are a lot of things that could make your waterproofing to fail. So have the both, a combination of the negative waterproofing, crystalline waterproofing, as well as an injection. This will solve your problem. Over to John.
Yeah,
John, please.
I concur with what you said there, Murthy. That's an interesting
Thank you, John.
example you gave. Yeah, I think, you know, to answer the question why it's not used more often is because people understand it as an admixture or an additive. So it's heavily promoted here as a complete waterproofing solution to a submerged concrete basement. So as an option or an addition to membrane tanking or without the membrane tanking. But the basic principle, the hydrophobic nature of the material means that whenever there is any moisture, just the slightest dampness or weepage of water coming in, it will react and it will crystallize, densify the concrete, and it will seal the concrete. So the way I've seen it used successfully is, as Murthy said, you can inject a number of times, and because the building is not static, we're not looking at big movements, but we can have some minor settlement, daily movements with thermal expansion and contraction, or annual movements. So you just need a millimeter or two movement of the structure, and your shrinkage cracks are, maybe very small, 0.2, 0.3 of a millimeter surface width. They can flex and open, and they'll also be developing with time. So the shrinkage is going on. It's an exponential process. So the contractor has some leaks, he injects it. It's okay for a month or two, and then it comes out adjacent. The crack extends either side of the injected length, and you inject again. So the leaks mainly come from construction joints or shrinkage cracks. So sometimes you can have just like patches of dampness, and the crack could be non-visible. It could be like a hairline crack, maybe less than 0.1 of a millimeter. And when the crack is very narrow, it's not possible to successfully inject that crack, even with a low viscosity resin. So in those cases, one option is to look at the crystalline waterproofing. If you have a very, very bad leakage problem, and you can't solve it, another option is to do what they call curtain wall injection. So you have to sort of take the affected area, you drill a grid of holes all the way through the raft to almost the bottom surface, and you inject an acrylic gel that reacts very quickly with the water to form an impermeable barrier. But I would say that is quite a drastic step to take, because you can compromise the integrity of the waterproofing if it's not done properly, and there is a possibility you could make the situation worse. So yeah, I'd recommend injection with PU, but that can be supplemented with the crystalline. Yeah.
Thank you, John. I think I'll take one more question. This is very interesting for me as well. So, this question towards Mr. Mohammed. Mohammed, you're in mute actually.
Yeah.
The biggest challenge is the substructure, as you know. So, how to assess a substructure, and what are the best methods? Can you please advise?
Well, one of the biggest challenges with substructures is accessibility and visibility. So if something you cannot see, you cannot really assess it. So with most substructures, especially with foundations, is that access to see what's happening. Second thing is the lack of information. So drawings, mostly, foundations done long time back. A lot of people don't keep records of their piling design, their footing designs. The soil reports are very important. For example, if you take the business area in Dubai, for instance, nobody knew that there's going to be a canal there. And you see a lot of buildings around that area that the basements are leaking, are not prepared for the water coming from the canal. So you look for the information and you don't find the information. And you try to look from the other side of the retaining wall or other side of the building, and you cannot access it. Either there's another building, there's soil came up, even the podium levels, or you have the water from the canal. So, and the last challenge is the repair methodology. If you have limited accessibility, you can't access the place that you can actually do the repair. Now, when it comes to bridges, then if you're doing bearing change or expansion joint change, then you have that accessibility, you know what's happening. I would say the most important thing when you look at substructures is try to do a visual inspection. You can get a lot of things from the visual inspections. You look for, structures sometimes speak to us. You look for cracking, you look for movement, you look for splitting. Deflections are a good sign of something happening. Settlements, if you look at the finishes of the block work, you see some diagonal cracks, that there's some kind of settlement happening. Joint opening, bearing damage, blockage in drainage. This could be also another sign. Color change of the material, moisture, humidity. So this is mainly, you can get that from the visual inspection. If you want to take it a bit further, then you can do some destructive or non-destructive tests. And my colleagues really mentioned a few of those. If we just want to mention it very quickly, the Schmidt hammer test, the coring, the ultrasonic, the GPRs, scanning, 3D scanning. If you can see the difference between the, say, PT and rebar, we're using the drape, but you need to read it properly. And then you can do carbonation, half cell tests, chemical tests, loading tests. Some places you can do a little bit excavation if you want to access the footing. So it is challenging, but there is solutions. And if you have the information, especially the substructure information or the foundation, it makes things much easier.
Okay, thank you, Mohammed. I'm sorry I cannot take up all the planned way of working because of the lack of time. We have reached almost 8:30. I'm sure you are the panelists available for all of us. We can approach, all our attendees can approach you whenever they need. The aim is to highlight the importance of the topic. Do not demolish, think twice before demolition. That's what the direction, that is the aim of this basically a workshop. Friends, today's takeaways are many. We have a panel of experts. We discuss with them. You may approach them directly, whoever they want. I know I cannot cover all the attendees' questions as well as my questions as well. I got plenty of questions still to go, but I'll be contacting you separately. Thank you very much, all the panelists, for the great evening. And for me, it's a great year for me as well because I'm stepping down from next year for this institution. All the best for all of my colleagues and my committee members and panelists. Thank you, sir. Good night.
Thank you.
Thank you, Sama.
Thank you, Sama. Yeah.
Thank you. Thank you.
Very good job you've done. Thank you.
Bye-bye.
Bye.
Bye-bye.
Very much. Have a nice evening.